Quantum computing. A quantum computer is a real or theoretical computer that exploits superposed and enlarged states and the intrinsically non-deterministic outcome of measurements as features of its computation. Quantum computers can be viewed as sampling from quantum systems that evolve in ways that may be described as operating on an enormous number of possibilities simultaneously through still being subject to strict computational constraints. By contrast, ordinary classical computers operate according to deterministic uses rules. A classical computer can, in principle, be replicated by a classical mechanical device with only a simple multiple of time cost. On the other hand, it is believed a quantum computer would require exponentially more time and energy to be simulated classically. It is widely believed that a quantum computer could perform some calculations exponentially faster than any classical computer. For example, large scale quantum computer could break some widely used publicly cryptographic schemes and physicists in performing physical simulations. However, current hardware implementation of quantum computation are largely exponential and only suitable for specialized tasks. The basic unit of information in quantum computing, the qubit or quantum bit, serves as the same function as the bit in ordinary or classical computing. However, unlike a classical bit, which can be in one of the two states, a binary, qubit can exist in a linear combination of twin blast states known as quantum superposition. As the result of measuring a qubit is one of the two states given by a probabilistic rule. If a quantum compute manipulates the qubit in a particular way, wave interference effects amplify the probability of the desired measurement result. The design of quantum algorithms involves creating procedures that allow a quantum computer to perform this application. Quantum computers are not yet practical for real world applications. Physically engineering both quality qubits has proven to be challenging. If a physical qubit is not sufficiently isolated from its environment, it suffers from quantum decoherence, including noise into calculations. National governments have invested heavily in exponential research aimed at developing scalable qubits with longer coherence times and lower error states. Example implementation include superconductors, which isolate an electrical current by eliminating electrical resistance and ion traps, which confine a single atomic particle using electromagnetic fields. Researchers have claimed and we are widely believed to be correct that certain quantum devices can outperform classical computers on narrowly defined tasks. A milestone referred to as quantum advantage or quantum supremacy. These tasks are not necessarily useful for real world applications. History. We will go into history later. Quantum computing is the in vogue. It is being implemented by governments across the world. Especially Andhra Pradesh has taken many strides. Andhra Pradesh government has taken in 15 years. The first quantum computer will be released, and Andhra Pradesh will have first quantum computer in the world, or one of the first computers in the world. So let us wait and watch who will win the race in the quantum computing. Sri Nara Chandrababu Naidu garu, Nara Lokesh garu taken as much much advantage over other leaders. So let us wait and watch. Thank you. Thank you so much.